So Paul Cappaert is a .NET developer for Dominos and loves doing web development in his spare time. And so I'm really excited to have him give this talk about using Python with Docker. So welcome, Paul. And Paul has given a few talks to the meetup, so I definitely appreciate all his contributions, and I'm looking forward to this one as well. So thanks, Paul.
Yep. All right, hey everybody. Is this sharing working right now?
Yeah, it is.
Okay. Yeah, I made a PowerPoint, Google Slides, but I only made 2 slides. But I figured we'd start there anyways, just to have something to look at. Really prefer to just sort of talk about things and then immediately jump into some demonstration. So let's get into what Docker is. But before I describe to you what Docker is, I want to talk about the problem, the pain point that Docker addresses. So if you're a very beginner with Python, Docker probably will not apply to you. But if you actually have a project you've been working on for a while, you're going to start to feel the pain of wanting to use external services, most likely a database of some kind. You might have some kind of data science work that you want to offload to something that's already done, maybe a program that recognizes images. I'm not sure. As a web developer, I think a lot about proxies is another one, another program you want to have running alongside your project, a memory cache or a message broker. And getting these things set up on your computer can be a huge hassle. And there are really 2 problems, which is first, when you want to set this up for your project, you have to do all the fiddling with the configuration. You need to install SQL Server, Postgres. And then if you have another project that uses it, then you have to make sure that they're not having some kind of collision. But then you also run into the second problem, which is that this is ultimately going to be different software from what you probably run for production, because most of you here, I'm sure, are either on Windows or Mac. And when you actually want to release something into production, you probably run on a Linux server. And specifically in the cloud, it's almost always a Linux server. You could do Windows servers, but actually the technology I'm about to talk to you really applies to Windows as well, even though I don't personally use that aspect of it. So what Docker allows you to do is run software in a standardized way across all the major operating systems, Mac, Windows, and Linux. And I can't even think of any others. It's really just those 3. And it allows you to do this in what's called containerization. And just to distinguish something here, Docker is a very specific technology. It's a company that released this software. It's pretty easy to use. Containerization is a concept that's actually been around since the 70s. Docker was really just the first big player to make it accessible and fairly easy to use. And so actually there are many different software solutions that use containers. Like probably everyone here has at least heard of Kubernetes. I'm not going to get into Kubernetes at all, but if you understand Docker, you're well on your way to understanding Kubernetes. So I'm not going to get too abstract here. I'm just going to jump right into a demonstration of running some software with Docker. So nginx is a web proxy, and by default, it just listens on port 80 on whatever network it's on. And I just picked this one because although it might not be that useful to you, it's easy to demonstrate that it is running. So I'm going to go ahead and just type in some Docker commands. I'm going to do Docker run -p 8080 nginx -d nginx. So what's happening now is unable to find the image for nginx locally. It's downloading nginx, and it's already up and running. So if I go to my web browser here, I go to localhost. Welcome to nginx, it's running. If I go ahead and do docker stop, and then I copy this long string right here, refresh, site can't be reached. So what just happened when I did this? Well, this first part, as you could probably guess, it's pulled this down from the internet. It downloaded an image of the container and then ran the container. And this container is contains nginx. which is the program I was talking to you about. And then I connected it on port 80 to allow me to get to it from the web browser. So what does that all mean? I'm going to jump over here to a whiteboard because I feel like this is a good way of understanding conceptually. Now we're going to get a little abstract. So you have your host machine. For me, it's macOS. That's something that constrains me. I've got to have my operating system and all that. One thing actually I run into at work is I also have a macOS for work. My macOS at work, the file system is case insensitive. Linux is case sensitive. So sometimes when you develop on the two platforms, there's little differences. And of course, every machine has a file system. It has ports. Both of these things are limited. Only one program can be listening on port 80 at a time, and I'm gonna show you a little bit more about that in a second. And then there's physical limitations like RAM and CPU, but actually we're thinking more about these particular resources. Now a container is a system, is something in your, it's basically, think of it like a little box within your computer. It's isolated from the rest of your system, and it has its own set of resources. And the way this is possible is through some very clever engineering that I'm not going to get into, but this container can actually be running an entirely different operating system. In my case, I'm running a Linux container almost always, and it has its own set of ports. And through the magic of virtualization, it's able to do this. It can't magically invent more RAM and CPU. So it's just using a share of that. It has its own file system. And then I was just showing you nginx. So actually, this container that I was just running has all of these things, and it also has a running nginx in it, nginx. Can't really write very well, but you can see that. So because this is isolated from the rest of my system, it has these resources, I can run this on any platform that I want. So if I have my host computer, I could also have a virtual machine in the cloud that could be running Linux, any particular flavor of Linux, could be Debian. And then I could have the same exact container also running nginx over here. So think of this wall as being by default impenetrable. The files are separate, the ports are separate, but you can create special little holes in this wall. And that's actually what I did in this command. You see I wrote -p, which stands for port 8080. What I did is I connected port 80 to port 80 inside of the container. So normally the network is also completely isolated from the outside world within the container. If I ran just docker run nginx -d, actually I'll just run it this time not detached, I'll connect to it. It's running, it's showing me the logs from this running container. It's launched, it doesn't have any configuration, so it's just listening on port 80. But if I try connect, did I refresh that? You see nothing actually happens because it's completely walled off from the rest of our system. We have to define those. We can also connect the file system if we wanted to at specific mount points. And other things that are limited like that. So for instance, I could, so I control C now. If we do docker ps, that shows us all our running containers. Oh, I actually did leave a couple of containers running from earlier. I'm going to stop those. Docker stop. Let me demonstrate to you something about this limited. Let's say I want to run two containers of nginx at the same time for whatever reason. Ports are limited. Nginx always wants to listen on port 80, but this mapping, I can actually customize it. Let's say I want to run this on port 81 on the host machine. So the host only has so many ports it can give out, but each container has its own set of ports. So I can run it exactly the same. So I can go ahead and do this command again. Docker run, actually, let me clear this so you can see a little better. And I think I'm going to mess this up, but I think it should be the host port first and then the container port. I'm not 100% sure. Nope, I got it backwards. I did. It's the host container. Okay. So you're never going to memorize commands. I always look these up. I have them written right next to me today, actually, except I forgot to write them in the correct order. There we go. Now we do Docker PS. Both of these are running. One was started 33 seconds ago, 2 seconds ago. So if I go ahead and go to localhost now, I'm connected to nginx, but now let's say I want to connect to port 81. I'm also connected. So this is just a really, I think you might imagine this could apply to your case, especially if you're doing some kind of big processing job. You might not want to have to mess around with threads at all. Well, you could containerize your little application, your Python app, and run it 20 times on like maybe a really powerful computer, and you'd actually be able to take advantage of multiple CPU cores, but still have a single-threaded application. Also, as I go along with this talk, I encourage anyone to, if they have an idea about how you could apply Docker to your project, if you want to chime in and ask, like, hey, could I use Docker to do this? I think that would be a really good way to lead this conversation, because I have my experience, which is in web development. But there's a lot more people are doing with Python, which is what I love about Python. Okay, let's see. So at this point, is there anyone that wants to ask a question or maybe has a specific example they want to chime in? I'll give people a couple seconds for that.
Just a quick question. Yes, Paul. Yeah. I want to know, are you going to talk about containerizing in the next part of the talk, about how to take a program and make it into a container?
Yeah, that's something I can. I had a couple things.
Not that you have to do it now.
Mm-hmm. Yeah. Yeah, containerizing. I think Docker, for most people, the initial way to use Docker is very useful, is just to run other software like a database. But you want to put your own software onto other people's computers, not just use other people's software. So actually, I could jump into that next. I just have a bunch of ideas to talk about here. Let me go ahead and do that. Well, first, so before we jump into that, I need to explain a little bit more about what an image is. I've explained a container. An image is basically just a container. I like to think of it as frozen in time and distributable across the internet. So in this case, I could draw it like this. We got nginx, and it was used. You could think of it. Something that's like dehydrated, so it's easy to pack up, and then you pull it down your system and you hydrate it, you get it running. In this case, I've pulled down nginx from Docker Hub, which is the default. Docker Hub is just like pip. If we actually could jump over to right now, you can look up all kinds of stuff on Docker Hub. It's just like the Python package index, but for containers. My favorite database, Postgres. You can pull that. There are also many different versions. And then, of course, there's the image for Python. And I guess actually that's one of the big things you can do with Docker is if you want to run multiple versions of Python, you can set your computer up to do that. I know that Dan talked about that a little last time, but Docker is one way. You could pull any of these versions. You could pull Python 2.7 if you want, if you don't want to have that on your computer. for whatever reason. I had a few things I had to run in Docker in Python 2, 2.7. So yeah, I think I could jump into an example of containerizing an application. Now I've got something open. I've already written it, so normally I type things out, but this is a Docker file, which is all you need to create an image of whatever your application is, and then distribute it and run it as a container. So every container has to be built from some base image. In this case, I'm running Docker 3.8, which is handy because my computer is running Python version 3.9. So what's going on here is first I'm going to pull from Python 3.8 dash Alpine. That does, actually not entirely sure what that means. I think Alpine is like a smaller image. Not entirely sure. I still don't know that much about Docker. I've been working on learning it. And then this next step copies this Python script that I've written into my running container. And then this command right here, this is the entry point. You'll notice that when I did Docker run nginx, it immediately started up. I didn't need to tell it exactly what to do. This is just a default here. So if we go and do Docker build, and then there's, I want to give this image a name when I create it. What was the command for that? It's a lot of different things you can specify here. I guess I won't give the name. It'll just have a default string. So I'm going to go do Docker build dot. So I already have Python 3.8, this image on my computer. So it doesn't need to pull it down. It is step 2, copy the script file, and then step 3, set up this thing. So it hasn't run anything yet, but now it's given the image this name. You can actually look if you run Docker images at all the different images you have saved. Over time, this will get larger and larger because it's very aggressive in terms of saving stuff. So I can go and do Docker run this image, and this script, you'll notice, all it does is loop through and print for 10 seconds. And so, yeah, that's what it's done. It's run for 10 seconds, printed 0 through 9. If I do Docker run -d, which stands for detach, I'm able to Docker ps. You'll notice here's my command Python script.py. And if I give it another second, it's not running anymore, because another thing to know about a container is it has to have at least one running process in it. And normally you only have one piece of software running in a container, although you can have more if you want. Because containers are so disposable and modular, it's ideal really just to have one program. And we could easily modify this to run forever if we wanted to, while true, I equals 0, I plus plus equals 1. And then we do another Docker build, creates a brand new image for us. Docker run. I'm actually not sure if we do this without detaching. I'm not sure why it doesn't show us the output as it goes. It might not ever show. But that is a very basic example of creating your own containerized app. And if you start from here, you can really, whatever script you have, as long as it's kind of contained within Python, you can run really any Python script within here. You probably need to have another step to do any pip dependencies. So I can actually, I think I've got something a little bit more advanced. Unless anyone has any questions about that. Oh, okay, if I close the container, then it'll actually show me everything is printed.
That was
Anyone
really
have any-
slick. Thanks.
Oh yeah, sure.
Hey, Paul, there was a couple of questions in chat. Now's a good
Yes,
time.
lay 'em on me.
Yeah, so Rick was asking if there's a way, or does this change the way you would use a virtual environment?
Well, you wouldn't really need a virtual environment at all because each container would have its own dependencies, completely fresh install. So I could add in here like run pip. I forget actually how to use this. Here, I can open up. I have another example. Open recent. I have an example using Fast API. Let's see. Yeah, pip. So if you could, in theory, if you wanted to, you could do all of your development within a Docker container, and then every time you made a change, you would need to trigger some kind of rebuild of your container, which actually isn't too hard. There are tools where you can do that. So in this Docker file, I've run pip install fast API unicorn, which are the two dependencies I need for this particular container. So yeah, does that answer the question? I still use virtual environments because I don't want to do all of my development within a Docker container. No.
Yeah, that answers the question. So like you could use a requirements file and then a run.
Yeah,
all the
absolutely.
requirements at the start of the program. Okay.
Mm-hmm. Yeah.
And then the second question we had from Che was he's developing an arcade game and Pygame. Could he use Docker to host it like in the cloud on a website or something like that?
Yeah, and that's, so you could definitely use that to run the back end. Like if you're making a multiplayer game, Docker would really help make that simpler in a lot of ways, because you'd be able to spin up multiple instances on your own host machine. But that does lead me to something I forgot to mention, which Docker pretty much can never solve problems in the space of direct user experiences. So you can't, Docker isn't going to help you make a mobile app or a front end app of some kind, or you wouldn't even want people to use a Docker container probably to as a desktop application. It's really more for running things in the cloud and then also on your development machine. You can actually think of it, containers are pretty good metaphor for shipping containers. They're standardized across the entire world, and that's kind of the same with Docker containers. There are many different things like Kubernetes, but you're not going to have a shipping container, however big they are. They're like 20 by 40 feet, something like that, or bigger than that. You're not going to have one delivered. You're not going to have your Amazon packages come in one of those, but they are extremely powerful in terms of every port in the world, all the ships in the Suez Canal, even if they're stuck. They all have the same exact size of container. Did that answer your question about your Pygame arcade thing?
Yeah, thank you.
So yeah, your client won't be running a Docker container on their computer. You're gonna need to package that up somehow. But in terms of running in the cloud, absolutely.
Paul, can I mention an example that you can elaborate on it? I'll tell you about. It's a thing called Rocker, which is an R package that's embedded in a Docker container. And when you run it, it creates port access to give you an analyst an interface that shows you the, it gives you the standard R display, which is multi-panel and has code and some things and stuff like that. So it's somewhat interactive, packaged in a Docker container. And maybe it's a special one, and it's called Rocker. So I don't know if it's common or if it's one of those oddball things, but that's one thing I know about.
Yeah. Well, if it's a tool for developers, that developers these days are likely to have Docker installed. So yeah, you could make something client facing if it's for people who just happen to have Docker. And first, yeah, consuming something like R, which is still really powerful, not as widely used. If I wanted to try something with R, I wouldn't bother installing R. I would run R in a Docker container, just because you don't have to worry that much about installing stuff when you use Docker.
That's exactly what it does. So,
Okay.
Okay. All right. Thanks.
Very cool. Very cool. That's a great example. Any other questions before I move on to some more examples?
No more questions in chat.
Okay, great. I'll explain a little bit more. I've glossed over this one. So here is an example of Fast API. It's a really simple library. This just defines an API that's, actually it has two endpoints, just focus on this one. But just has a path right here. If I make a GET request to this, it's actually really similar to just nginx, like I just showed you. If I just make a request to the server, it'll return this, and I'll actually turn this into JSON, which is great. And it can also turn arguments into things. So if you just wanted to make an API, Fast API is great. And then here's the Docker file for it. If I start from Python 3.7, although I could really start from any Python, and then I install Fast API and Unicorn. It's the only two dependencies I need. Otherwise, I would probably set up a requirements.txt and then install everything from that file. Expose port 80, so the container knows that port 80 is what I'm going to be listening on. Copy the contents of this app folder into the same folder in the container, and then it'll run this command. So this is just, Unicorn is actually a pure Python async ASCII web framework. So don't worry about that, what that means. It just makes it possible to run stuff on the web. So I'm going to go ahead and do Docker build this. And it's giving me an image tag right here, Docker run. And I'll go and do -d. And I'll hop over to localhost. Oh wait, forgot about nginx. Docker PS, I can see all of my running things because I didn't give it a nice name. I can't just stop it without looking it up. There we go. What did I do? Docker stop.
Yeah, you didn't tell it to stop, I don't think.
Ah, right. Oh yeah, I keep forgetting. I'll show you in a minute. There's a much easier alternative to doing all of these things by the command line. I stopped my two containers. I ran this. Now if I go to localhost though, I can't see anything. Can anyone have any idea why can't I connect? It's running. If I do a Docker PS, oh, I did. Okay, if I do Docker run -d, this image.
Yeah, it shouldn't have showed up in your list before.
Is it just
No.
exiting?
So if I do Docker PS, it is exiting.
So it's got to have a running process.
Yeah, and I left the command. Oh, I didn't save my Docker file, of course.
Mm.
That's the thing about VS Code, that'll get you. Docker build this directory. I've got a new container tag, Docker run. Okay. And now, does anyone have any idea why I can't connect to my thing? If I do Docker PS, you can see, okay, now it is running. Did I hear someone say it?
Did it tell it what port, like localhost, is that specific enough?
Ah, yeah, see, I did not tell it what port. And as you recall, by default, you got to totally solid wall around your container. So let me go ahead and stop this bad boy. And I'll go ahead and run -p 80 80 just to make things simple. And now, hello world. And I can even go to, I think I defined another path in this. I can go to items and it'll actually have a little bit of Python going on there. What is this queue here? Is actually not sure what that is. Okay, so that is a little bit more on creating containers. Any more questions about running your Python script inside of the container? Creating an image, I mean, and then running it?
So even though the code said to expose 80, your Docker command still you needed to tell it to in the implementation of the container, you needed to give it explicitly open that.
Yeah, that's
The container
because
can't internally decide to do something. You have to
yes, you're right.
tell
It cannot.
I see. Okay.
Yeah, that is an important concept. Really, from the perspective of your Python code, it has no idea where it's running. It thinks it's running basically on a Linux computer. Or if you can actually create a Windows environment. I think there might be there might be a Python image based on Windows. I don't know why on earth you would want to do that, but you could if you wanted to. If you wanted to run maybe a .NET app, it would be Windows. But yes, it has no control over the host machine. It has to be explicitly given. So if you ran this in the cloud, you would probably expose a different port than 80, and you'd have a load balancer standing in between your Python app and the entire world. You might even have some security gateway too. It could be a whole setup. So that's really one of the things that Docker gives you is when you've created your application as a container, you can run it in a very flexible manner, especially if you limit the number of resources that you use. So I'm going to go, because I've done all these commands now. Commands are terrible to memorize. But I've been using Docker at my job for years, so I have memorized a fair number of commands. I'm going to start showing you a tool that's sort of one layer higher than Docker, which is Docker Compose. So I went ahead and created a directory specifically for this. So Docker Compose allows you to write a markup script which says what containers you want to run, and you can define all the attributes we were doing in the command line. And you can do it just for one container if you want, but you can actually have many containers defined in one single file. So I will go ahead and do a simple one here. That's just like our beginning example. Go ahead and define a docker compose.yaml. If you're not familiar with the YAML syntax, it's just a markup language. It should look pretty similar to Python. It uses tabs to show hierarchy. So we start by defining our services is one of the things that we can define. In a minute, we'll talk about volumes, which is really cool. I'm going to go and just give this service the name proxy. Oops. And now our proxy, we give it certain, it also has to start from an image like we're talking about. It's going to be nginx, just nginx actually. Don't need to define a version. And then we say ports -80. Now you'll notice this is very much like the command we did, but now it's file, so we don't have to worry about typing that exact command all the time. So I can now use, instead of Docker, I'm using the Docker Compose command. It's a separate tool, but if you install Docker, this should come with Docker. You do Docker Compose up -d for detach. I always do that. I guess I could try without. No, I'm always going to detach. That failed because ports are a limited resource on a computer. So I have to go and shut down my fast API container. But now I can do Docker Compose up. And it went ahead and it found the Docker Compose file, and it did what I wanted it to do. And now you don't have to worry about copy pasting the name. I can run Docker Compose down, and it will take this container, stop it, and remove it. So this is pretty handy. I'll show you a little bit. Does anyone have any questions about that? Because I'm going to get
Where
a
did
little
the
bit
name
more
come from? Oh,
conceptual.
sorry.
The name come from for Docker Compose?
Yeah, the MyPy Docker proxy one. Is that?
Oh yeah. Well, here's the directory, and then the directory is MyPy. So Michigan Python Docker is what I named this directory, and then it's the name of the service, and then it always does things numerically like that. Because on the host machine, the name, if I go and do Docker Compose up again, and then I run Docker PS to see all of my running containers. This container, yeah, it has the name. This name has to be unique. So combining these three things together, it's going to be something unique, basically. Just a little thing. And so it's more human readable. If you do a Docker PS, you can actually see what's running. Anyone else, any questions about Docker Compose? Or just general questions if you have any
And a couple
ideas about.
questions in chat.
Oh yeah.
Xander asked what the resource requirements are. Is it more efficient than a virtual machine?
Yeah, so I didn't want to get into, a lot of people start talking about Docker with virtual machines. I never used virtual machines before I started using Docker, so I kind of thought, but if there are people here, I talked a little bit about the beginning about clever engineering, and Docker containers are much more efficient than virtual machines because containers aren't actually really fully isolated. They use a bunch of different clever things, one of which is, I'm running on a Mac, and when you install and run Docker, it's actually running a lightweight Linux virtual machine in the background at all times. But each Linux container is actually using what's called the kernel of the operating system. And it's actually sharing that. But it's using a couple things to keep it isolated. There's something called C groups, which keeps processes isolating, so it doesn't allow them to affect each other. But they're sharing a lot of the same resources. Whereas if you ran two virtual machines on a single host, they would be completely separated. And sometimes it's the case that you want completely separated things. There are some practical reasons for that. Sometimes I guess it's security. Virtual machines, I guess, are I'd say a little bit more secure than containers, although containers are pretty well known at this point. Docker is an open source project, has tons of contributors. Wouldn't be too worried about that. But in short, Docker containers more efficient than VMs in terms of resource utilization. And they're super fast, as you noticed, to start and to stop, which just makes them great for the cloud. And I'm going to get a little bit here at the end into what you can do with the cloud with containers. Any other questions in the chat, Dan?
Yeah, so thanks for that. John had a question about if you run Python via Docker and then typed in a command like which Python, what path would come back?
That is an excellent question. I think I'm just going to go off the cuff here and do Docker run Python. So this is actually the Python container. It doesn't have an entry point, so I think I need to type in /bin/bash to actually run within this container. Oh wait, I need to add a little bit of context here, -ti. This just allows me to interact my terminal directly with the container that I'm running. Wait,
Does TI stand for terminal interface or something?
is it? I can't remember off the top of my head. It's SH. I knew there's, I really want to, this is a little off the cuff. I really want to show you this though a little bit. You can actually go into this container and it's just I have my book here actually. I can real quick. There we go. I can do any Linux command that I want. So as you can see, you might recognize this. This is the Linux directory. It's a completely new file system. And I can do which Python. And it's located at user local bin Python. Do pip list. I can do pip install Django if I wanted to. I might not have a good example because it'll take a minute now, but it's able to reach out and then install it. So pip list. The thing is, it's installed as packages. I can go ahead and exit this back on my host machine, Docker PS. Now nothing's running, so that Python container is stopped. If I do ps-a, we can see here it's exited. Actually, it's probably at the top, exited about a minute ago. And I can go ahead and remove it.
Hey, Paul, so those changes you made
Now it's just gone.
to the container, those aren't saved after you.
They are not saved.
After you, I guess, close out of the terminal, is that right?
After I close out of the terminal, they actually are saved. But what I've just done now is I've removed the container. It's now gone. So the changes are now really gone. I could have started the container back up again. So containers, yes, you can have stuff persisted in containers. You can save files. It's just really not recommended because containers are thought to be generally disposable. And that actually really gets me onto my next point, which I'm going to talk about volumes, which are, try not to load too much, but volume, I can imagine you're all thinking about, wait, how do I save data if containers are disposable? Volumes are like containers, except there's no running software. A volume is really just an isolated, separate file system that Docker also manages. So instead of a square, I'll draw a circle, and then you link them up, and then you can throw your files in here. So I will show you an example of this with MongoDB, which is a database I don't use particularly often, but it's really simple to get started. So I'm going to go ahead and just define here. I've got it's typed out. Mongo script.py. I already installed this package from py mongo import mongo client. Client equals MongoDB localhost. And I actually have Mongo running on my computer on the default Mongo port. So I'm just going to go pick a random port. I'm just going to pick 30,000 as this new port. Now I just need to do a few things. I need to get a database from Mongo. So this will either find or create a database. And then within that database, I need to have a collection. So from that collection, from that database, I create a collection. I'll just go to mycol. And I'll go ahead and collection, insert one. And if you're not familiar with MongoDB, it's a document database, which really means you can throw any old dictionary into MongoDB and it will just accept it. It is extraordinarily flexible, which is kind of a curse sometimes, but that's a whole other question, whole other issue. And now I want to show you that it's saved. So I'm going to go ahead and just loop over every entry that now exists in this collection. I think I got all that syntax right. So now I've got a simple script that needs MongoDB to be running on port 30,000. So I'll go and create a Docker compose. Oh wait, I already did that. I'm going to overwrite this Docker compose, define two services. No, just one service. And a service and a volume actually. So the service is going to be my MongoDB. Image is going to be Mongo latest. Actually, I don't need this latest tag. That's really the default. Ports. So the my host machine, I'm going to be using port 30,000 because I already have MongoDB running on my system. Don't want to interfere with that. And then inside the container, Mongo is running on its default port, which is 27017. Now I'm going to get into volumes. So what this does is similar to how I've mapped a port on my host machine into the container. I'm going to be creating a new volume. I'm going to call it DB data. And inside of the container, this exists in the data/DB directory. So now those two things are connected through what's called a mount point. So anything that's saved in this directory will actually be saved in this volume that's managed by Docker and will outlive the container itself. Then I'm going to, don't really need to do this part, but you can also have the configuration information in its own volume. So you can have the configuration and the data live separately. I'm not changing the configuration at all, so it's rather moot. But now I'm just gonna, similar like how I define my services, I'm gonna define these volumes, but there's nothing special, they just exist. They're just file systems that are sitting inert on my computer. Okay, so I think I've got all that right. Now I can do Docker PS, just let's leave that running. Docker compose up -d. And it created this one container. And it'll also have created these volumes. And now I can run my script because it's relying on port 30,000. So Python Mongo script.py. And okay, so I already did this earlier. So there's already a couple entries in this database in the volume. Even though this container is brand new, the volume already exists. If I run this again, now there are 5 entries. If I run it again, we can go and take a look at this volume, Docker volume ls. That's what it is. We've got should be the name of it should start with Mongo. Should start with mypy Docker. Yeah, here it is, DB data. So we can go ahead and Docker remove. Actually, I wouldn't be able to remove it because it's being used, it's linked to a running container. But what I can do is Docker compose down -v stands for volume, and it will not only this, I could first show you just the regular down, sorry. This will stop the container and remove the container. So that container no longer exists. Any changes inside the container would be ephemeral. What if I do Docker compose up? Oops, I forgot to detach. I could just open another terminal. And now I'm running my virtual environment. Python Mongo script. There we go. I've got my 7 entries now. I'll go and stop this. So stopped Docker. I have to start it again in order to run this. Detach. Docker compose down -v. Interesting. Not sure what this error is. Docker volume ls. Let's see if that volume is still there. Interesting. The volume still seems to be there. Might not have prepared this part so much. Oops. Okay, so I didn't get rid of the volume just then. Interesting. Said it has something to do with the network. I keep forgetting to do detached.
Do you have to run like Docker network disconnect first or something?
That's I'm not sure. So yeah, it has a default network. That's an entirely separate concept. I still haven't really mastered. Well, yeah, clearly haven't. A lot of times I define a network with this. I can actually open another project. Haven't worked on this one in a little while. Do I define a network on this project? This one has 2 services running. It's got a little bit more configured to it. Has a volume. Not sure why that's not working.
So is the volume a flat file, or is it a file system that persists after the container's gone?
It's a file system.
Wow.
Yeah, that's my understanding at least. I haven't dug into volumes as much.
Mm-hmm.
It's not a single file.
Mm-hmm.
I'm not exactly sure how it's stored. They are portable to some extent. Like you could.
That's what I was wondering, if people move it around, or if they just sort of stay where you're using it for that container history. Instead of regenerating certain things, you know, you could read and spin up a new container, but have something that you use every time, I guess.
Yeah. You can have volumes belong to multiple containers. So you could have your database have a volume to store all the data, and then another container could do a periodic backup of that volume. I haven't dug into that because usually if I'm running in the cloud, I would use some kind of either a managed database or an S3 bucket of some kind. I wouldn't even want to bother with this. So anyway, so far with that, any questions? Clearly, I'm a little not 100% sure on the volumes, but I don't want to be held up by this. So,
Any other questions, anyone?
all right, well, since I promised cloud, I didn't actually get around to preparing to do proper demonstration. But one of the ways you can run your containers in the cloud is there's actually a number of services what you would call serverless, where you can actually, if you self-build a container like I've done with Python and upload it somehow, it'll essentially just take that and run it. However, and you can specify things like, I want this container to run and it's going to be open to the internet. So one of my favorite examples is a Google Cloud Run. So if you have some image, you can tell Cloud Run like, hey, I want you to run this. And Cloud Run will only run stateless apps. So you have to be okay with the fact that your container will be run, but then it might be removed and replaced, which is really ideal though, because it's a great way to update things. I could even start, I'm not sure how hard it would be to even start a Cloud Run project just right now. These things actually are pretty easy these days. I don't think I have any billing information saved with Google Cloud Platform, so probably not. Yeah, I haven't even verified my identity. There's Google Cloud Run, there's Azure container instances. So one of the big selling points of these is these services is that they will scale up automatically. So if you start to get more traffic to your app, they will actually add more and more instances, and they will bill you based on how much compute you use over time. They won't just charge you a flat rate. You have to like rent a virtual machine. And there's all kinds of free promotions out there that people can take advantage of. So if you want to run your app on the web somehow, make it accessible across the internet, one of those container services is really what I would recommend. And I think that's pretty much all I wanted to cover. It's been about an hour now, so anyone else have any questions?
Any more questions, anyone?
Yeah, maybe anyone else have any cool projects that they might want to do Docker on, or even if it's just an idea for a project, you can go and bring it up, because I love seeing what people want to do with Python.
So yeah, just in general, Paul, would you build like a Django web app or some web application as a Docker in a Docker container, and then deploy the Docker container to the to whoever's hosting your site? Is that what you would do? That's probably a naive question, but is that the way you would keep all the dependencies?
That's the only way I would do it, actually. I would not want to deploy a Docker to deploy Django on a bare virtual machine, because the whole DevOps thing you can do now. You can automate the process of building that container with Dockerfile, with the Docker Compose, and then run tests against that automated environment. It's you can save it basically as source code. So this Docker file, Docker Compose file, and there are other things you can do to specify your environment. You can save them as code inside of your Git repository. So if for some reason, like, oh, I have to move from one cloud provider to another, well, your virtual machine is all configured and set up perfectly on one cloud provider. And now it's kind of not really replaceable because you've set it up perfectly right there. If you're using Docker to deploy that, then you are probably less stuck there. Things are more repeatable. And I can show you, actually, this is an example of a project I did at school. This is the Docker Compose file where I have a Django project. On my own machine, I'm not running in a Docker container, but I am running Postgres in a Docker container, so I don't have to install Postgres on my machine and configure it, and I can just set the environment variables, everything that I need. Redis is another app that we need for this application. Anyone else?
Are there any resource configurations? So I'm guessing, so just by your machine and the external volume would grow? Or I didn't see you like specify, oh, this is going to get a gigabyte space.
Right. Yeah, that is something you can actually do with Docker. Is you can, when you run a container, you can actually specify how much RAM it's allowed to use, which when you're in production is a really good idea to do, especially with cloud providers I mentioned. They'll bill you based on like how much CPU you use. You can specify those constraints with containers, and that's also good for testing. You want to probably test your app with only a certain amount of CPU available to it. So that is something I actually have not really gotten too much into. That's something you can also do with Docker and really any container runtime.
So you just had defaults running, but there's things you can specify.
Yeah, I just let it use as many resources as it needs to do its work. Pretty much never use any resource constraints on my own local computer. That's more for production.
Thanks.
Hey, Paul, I know often in the meetup when people talk about deploying things to the cloud, they mention Heroku, which I think is a little bit different. Do you have any thoughts on like the ease of using something like Heroku versus, I guess, building a Docker image and deploying it to one of the cloud providers you mentioned earlier?
Yeah. Well, let's see. Heroku is the first place I started with Django because Heroku makes it super easy to deploy stuff. But actually, Heroku is just using containers on their end. They just make it a little simpler than defining a Docker file. You just define with a proc file, and they already know about pip installing requirements.txt. You just get a very simple. I don't even really need these other lines. You just need to say, hey, my app Django application is here. But actually, Heroku can run Docker containers. And actually, that's kind of the way I prefer to set those projects up now, because it allows you to run the same thing on your local machine as on Heroku. But Heroku is really not far off because from using something like Cloud Run, because the instances of your application on Heroku, they call them dynos. They're just like containers, though. They're stateless. You don't store anything inside them. You use a separate database, which Heroku can also manage. So that's not far off, really. Most people actually, Heroku can get them pretty far. I would actually just use, I would use Heroku for your production environment, and then Docker as your local environment, which is what I have set up in this project. I don't have a Docker file, but I do have Docker Compose just to run the dependencies. And this is really helpful for setting up new developers. Tell them to install Docker, clone this repository, and then they run Docker Compose up, and they are just ready to go. They do still need to set up a Python virtual environment. But they don't have to fiddle around with installing Postgres and Redis.